Hello and welcome to all. I hope you all are doing great. Welcome to the new chapter, that is the chapter 9, sequences and series. The lesson 1 is sequences as functions. I am sorry I was not able to record for a few days because I was sick and ill. Now I'll be starting the new chapter for the first lesson in the coming videos. So please do stay tuned, and if you have not yet subscribed to my channel, please do subscribe. It will mean a lot to me. Now this lesson has the learning objectives, that is relate arithmetic sequences to linear functions and relate geometric sequences to exponential functions. We will look into both of these in the coming sections. The keywords in this lesson are sequence, finite sequence, infinite sequence, arithmetic sequence, common difference, geometric sequence, common ratio. There are plenty of these words, but as we move on into the lesson, we will come across these one by one. Now, about arithmetic sequences, you can see these numbers over here: -6, -2, 2, 6, 4. You can see there is a relationship between all of these. There is a number that is added to all of these. The 4, number 4 is added. You can see -4 plus 4 is -2, -2 plus 4 is 2, and when you keep on adding 4, you get these numbers. So now in arithmetic sequence, each term is determined by adding a constant value to the previous one. So constant value, it does not change, the same number is being added. That is what it means in arithmetic sequence. And this number which we add, the constant value, is the common difference denoted by D. And now over here, these usually have a particular order or pattern, and we can find them. And before that, if we have been given, say, a limited numbers, you can see over here the limited numbers. This is it: -2, 0, 2, 4, 6. No more, no less. They have given limited numbers. They are finite, countable. Whereas infinite will be denoted by the three dots. That means it just goes on: 0, 1, 2, 3, 4, 5, until infinity. That's why it's called infinite sequence. And these are generally denoted by these A1, the first term, A2, A3, and so on. Now, sorry, over here, sequences as functions. Now, the main thing is, the few of the important thing is, the terms, whichever will be given to us, A1, A2, A3, is always the range. This is very important and crucial. Because if they have asked you to graph, what do you understand by graphing? You need x and y, right? X, y. So which is the x values? X value is the domain. The first term will be 1. Second term is 2. Always this is standard. The range, the numbers which we have, now say over here, this is the finite sequence, right? The domain over here is 1, 2, 3, 4, 5, whereas the range 1 over here is 3. 2 it's 6, 3 is 9, and I'm sure you get the pattern. It goes on like that. So it's very important to know what is the domain and what is the range. So that's the thing. Now in this case, when it's infinite sequence, you need to start. A domain is obviously all natural numbers, because it can be it just keeps on going. But there is one important thing: range. What about range? You should start over here, and you can denote it like, see, it's 3, 6, 9, 12. It's multiples of 3. So you can tell it's multiples of 3. And natural numbers means it starts from 1, 2, 3, 4, and 5. It goes on. Okay, natural numbers. Not integers, it's natural numbers because we start from 1. I hope this is clear. So now with this basic understanding, we can start solving problems in sequences as functions. We have first problem: identify arithmetic sequence. Determine whether each sequence is arithmetic. Now this is the question. Over here they have given few numbers. Let's take them. Let's take those numbers. Let's see whether we can add anything over here or no. We need to, okay, the best way is, before this, what the easiest way would be, take the second term and subtract the previous one. -6 minus 5. What is the answer? -11. Try the same thing. next term with the previous number, minus 7, minus of minus 6. You can try it in calculator, but minus 17 plus 6 would be minus 11. So what happens over here? The constant difference or the common difference is 11 in all the cases. And in such problems, the common difference is minus 11. And yes, the sequence is arithmetic. That's how we can solve it. Now here, let's see another problem. Sorry, I by mistakenly pulled it up. Uh, okay, this one. Okay, I would request you to pause the video now. Everyone, try pausing it. Try some things like subtract the second and the first. Try to get the answer by yourself, and then try to say whether it's arithmetic or no. I hope you tried the problem by pausing the video. Now let us solve it together. What you can do is take the second term, 12 minus of minus 4. What is the answer? It'll be 12 plus 4, that is 16. Now let's try the second case. 28 minus 12. So 28 minus 12 would be again 16. Same thing over here. 42 minus 28. 8. Now over here, 42 minus 28. So what is it? It's not 16, it is 12. Sorry, it's 14. And no, it is not arithmetic sequence. See, over here, this is the problem. When the first, yes, it was 16, but the next case it was 14, which means no, the common difference is not constant. I mean, there is no common difference. Common difference means it must be same addition, same number all throughout. But over here, the last term, it was not same. So it's not constant number that's being added to the previous term. There is no common difference in this case, and it is not arithmetic sequence. So this is how easily we can identify arithmetic sequences. In the next sections, we will solve more interesting problems in arithmetic sequences and geometric sequences. Let us now graph arithmetic sequence. Here we have to graph this particular sequence, 18, 14, 10. We need to first find the next four terms of the sequence and then graph the first seven. 3 plus the next 4 must be graphed. Now first let's find the next four terms. You need to find the common difference. Remember, they have already mentioned over here this is an arithmetic sequence. So don't start subtracting, keep on doing for all the terms. No need, because it's already arithmetic sequence. So it will just be 14 minus 18, or you can use the any two terms. It's up to you. 10 minus 14. I'm just doing this both to show you the answer will be the same. Now the answer over here would be negative 4 because negative 18 is bigger, and negative 14 minus 10 would be, sorry, negative 10, negative 14 plus 10, sorry, I got confused, is minus 4. So the answer is minus 4 even in any of the cases. So once they mention its arithmetic sequence, it will be arithmetic sequence. You do not need to double check each of the cases. Just find the common difference in any of the two terms. Then once we find it as minus 4, you can keep finding any number of terms by adding it to the last term. So now if I keep on adding the negative 4 over here, I'll keep on getting the next term. It'll be 6. Then keep on adding minus 4 over here. It'll be 2 minus 6. So those would be the next term. That is, keep adding minus 4 to 10. It'll be 6. Then it'll be 2 minus 6. You can do it easily in your mind. Now you have found the next four terms. That is, these are the next four terms. You need to graph them all. So graphing is very simple. The next four terms are these. You need to have domain and range. So in the previous section, in the previous video, we already saw the domain would be just natural numbers. It is natural numbers, not whole numbers. You don't start with 0. It's natural numbers or counting numbers where we start from 1. But in this case, they have asked for 7. So 1 to 7 would be your domain. Always this does not change. If it was 10 digits to graph, it would be 1 to 10. Or it depends on the number of digits. So after that, what you do is basically find the range. Range is these digits, I mean the sequence 18, 14, 10, and the next four, whichever we found out. So these are the range. Now, graph these. How would you graph? Very simple. See, the domain is 1 over here. So take 18, that's the 16. It's 4, the slope, I mean, the constant difference over here, the line. I'm not getting the exact word now. Anyways, it is 4. So this number would be 20. So here in the middle, it'll be 18. So this is the graph. Now, what will be the next thing? 2 over here is 14. So over here, and same way you can see it is a linear graph. This is very important. When you graph arithmetic sequences, it will be linear graph. Okay, the scale. Okay, before I forget, it's very embarrassing. I couldn't remember the term. The scale over here for 1 unit is 4 units. So 1 unit over here is basically 4 digits. So that is the scale. So that's why over here. Anyway, this is very basic graphing. I'm sure every one of you know this by now. So this is how we graph it. Only the thing you must remember is the domain. Remember, the domain is always natural numbers or counting numbers. It starts from 1, 2, 3. It depends on the number of terms you have. So that is the domain. The range, the y value, domain is the x values, right? It will always be 1, 2, 3, and so on. You must start from over here 1, positive 1. The range is always the given sequence. So that is it. So if you remember so much, it is very easy to graph. Let us see another problem, a real world problem where we need to find a term. So during their routine, a high school marching band marches in rows. There is one performer in the first row, three performers in the next row, and five in the third row. This pattern continues for the rest of the rows. Determine how many performers will be in the 14th row during the routine. So now over here, since we are just beginning the function, we are not using any formulas of arithmetic sequence or series. We will be able to solve similar problem like this easily in the coming lessons. But for now, we will use the point slope method and solve it. Because over here we can see that the slope, the common difference, the change, that is like a slope, isn't it? We saw in the graph the slope was constant. The slope means the change in the y-axis to the x-axis, dy by dx here is always constant. That is 2, I guess. See, the first row it was 1, the one performer in the first row, that means there will be only one performer over here. Three performers in the next row. One, two, three. Five in the third row. One, two, three, four, five. Okay, and it goes on. So this is the thing. You might have easily guessed the next one would have 7 and then 9 and so on. So how do we know? Just you can find the slope by 3 minus 1 will be 2. So that is the slope. So now over here that slope is m. And they have also mentioned in the first row and the third row, there are five. So we can consider any of these and you will get the same answer. It's fine. So now if you consider third row, that is the x value, the domain, right? It starts with 1, 2, 3. And the y value or the sequence is having 5. So this is the y value. That is the y value. So x1 is 3, y1 is 5. And what do we want? We need to know what is happening in the 14th row. How many will be there in the 14th row? So the rows are 1, 2, 3, 4, 5. That is x. X is 14. At x is equal to 14, what is the y? That is the question. So we can use the point slope formula. Over here, you can substitute all the known things. So 2 is known, the slope, the given value over here. What is the x1? That is 3, y1. And now here everything is known. You can simplify it. Just multiply the 2 over here and take this over here. You got the equation. Now what is this equation? This equation is a linear equation because over here y and x is there. Y is equal to 2x minus 1. Now you can see the slope, it's increasing something like this. Now, you want to know what is the y value at x is equal to 14. At x is equal to 14, sorry, this is x is equal to 14. What is the y value? Okay, we can easily find it. Just substitute over here x value of 14 and solve for y. Replace, solve it. You're going to get the answer is 27. So this is how we can solve it by point slope formula. Otherwise, you can just keep on adding, 1, 3, 5, 7, 9, 11, 13, and it goes on. And this is 1, 2, 3, 4, 5, 6, 7. Same way, if you do another 7, you will get it. So if you add about 14 over here, 7 is a 14 plus 14, that will be 27. So that is the answer. You can double check this in various ways, but in the coming lesson we will find more easier method which we have not yet introduced you to the formulas or anything. So stay tuned for the next videos, the next lessons. We will learn much easier method to solve these problems. Now we move on to the geometric sequences. These are similar to the arithmetic sequences, but the only difference over here is we don't have a common difference. We have a common ratio. A ratio, that is, something is being multiplied every previous term and you get the next term. So now, for example, you can see over here there is a number multiplied. The number is 4. When 4 is multiplied, you get this. Same thing over here. What is multiplied? Same term, 4, and you get 1. 1 by 6 times 4 is 1/4. 1/4 quarter times 4 is 1. 1 times 4 is 4, and then it goes on. Okay, that is very, very wrong of me. It is supposed to be 16. I will change this in a while. I'm sorry for that. Okay. I hope you understand. 4 times 4 is 16, and it just goes on. So this is geometric sequence. Here in a geometric sequence, each term is determined by multiplying a non-zero constant to a previous term. Obviously, it can't be 0. If you multiply 0, you're just going to get the same thing. And the constant value is called the common ratio, and it's not r, it's r. Okay, sorry, I was very sloppy in doing this presentation. It's r over here, and these terms d and r you will learn more about in the coming lessons. Now let's see a problem over here. Determine whether each sequence is geometric. We had subtracted second term minus the first term in the arithmetic sequences. Now, what do we do in geometric sequences? Again, I see another mistake, that is, this is geometric. As you might have known, I was not able to do all these presentations for a few days. So I was trying to do all at once, and because of the hurry, I've done plenty of errors. I apologize for that. I will try and edit all these and re-upload the file in the Telegram groups. But for now, let's solve this geometric sequence, whether or no this is a geometric sequence. In the arithmetic sequence, we subtracted the second term minus first. Here, since we multiply the term, just divide these both. 6 divided by 2. What is the answer? Sorry, it's minus 2. It'll be minus 3. Same way, next term divided by the previous term. It'll be minus 18 divided by 6. It'll be minus 3. 54 divided by minus 18. 54, 60 minus 6. Yes, again, it will be 18 times 3 is 54. That means, yes. So you're being multiplying over here, minus 3, minus 3, minus 3. How do you get this ratio? Find the ratio. 6 divided by minus 6. The ratio is the common ratio. So over here we get the common ratio. Therefore the ratios are the same basically. So it is the geometric sequence. Similarly, we can see another problem. I would highly recommend you all to pause the video now and solve this by yourselves. I hope you have at least tried by pausing the video, at least some of you. Now let's see over here what is happening. 16 divided by 8. Okay, 16 divided by 8 is 2. But when we divide 24 by 8, sorry, 24 by 16, No, it is not 2 because 16 times 2 is 32. This is, it'll be 8 twos are and 8 threes are, it'll be 3 by 2 or 1.5, which is not the correct answer. So this is not, we are not getting the exact ratio. See, it's 2 and it's 1.5, and over here we are getting 1.333 consecutive threes. So if it is it's recurring, always 1.333, you put this dash over here. This denotes it's continuous threes that goes on. So these are not same. So the ratios are not same over here. So the sequence is not geometric. So this is how we can solve the basic problems. In the next videos, we will see a little bit more problems regarding graphing and other things in geometric sequences. The example 5 is to graph geometric sequence. Similar to what we had done in the previous section where we graphed arithmetic sequence, the same concept is used over here. Only difference is we need to use a common ratio. Now we are being told to consider the geometric sequence, in this case 3282. You can use any of these two digits and find the common ratio. You can take the first and second, it'll be 8 divided by 32. But since we know this is geometric sequence, this must be equal to 2 by 8. Isn't 2 by 8 more simple to solve? It's 1 and 4. So it is quarter. Even over here, 8 one times, 8 four times, but usually take the least number or the easy numbers. So we know the common ratio is 1/4 or quarter. So that's the common ratio. And then we need to find next three terms. Keep multiplying 1/4 over here, quarter of 2, and so on, and you will get the answers. So multiply quarter, you will get half. Multiply quarter again, you'll get 1/8. And then last time when you multiply, you'll get 1 by 32. These are the three terms. Half, 1/8, and 1 by 32 1 by 32. So we need to graph all the six terms. Now, same thing. The domain is always the natural numbers. It starts with 1, and over here there are six terms, so 1 to 6. The range is 32, 8, 2, and the three numbers we just now found out. And it's very easy to graph. Take an appropriate scale and graph. Over here, 1 is at 32, so this is 32 and 1. The scale is 4 each units over here on the y-axis. At x-axis, it's always 1 unit, 1 scale. And 2 is at 8, 3 is at 2, and then you can see 4 is at half, and it just goes on. Now this is an exponential graph. You can see over here, this is why geometric sequence is called exponential, whereas arithmetic sequence is called a linear graph. You will get a linear graph. So this is how you graph it. It's very, very straightforward. And the last type of problems in this is to classify these sequences. You have been given various sequences and you need to solve them up and find whether it's arithmetic, geometric, or neither. Let's do them one by one. Now this first one, check for the common difference. Subtract. You know, two terms must be subtracted. Over here it starts from the last one. 54 minus 36 is 18. Let's do 36 minus 24 now. It is 12. You can stop over here because the common difference is not same. No, it is not arithmetic sequence. Sequence and series is two different thing. If I tell arithmetic sequence and if I tell arithmetic sequence, they're not the same. Okay, I mispronounced and I just told by mistake arithmetic series. We will study that in the coming lessons. But for now, arithmetic sequence is what we are learning. But this is not arithmetic sequence. Let's check for the common ratio. Divide them up. So 54 divided by 36 is 3 by 2. 36 divided by 24 is 12 goes. It's again 3 by 2. And lastly, yes, it is 3 by 2. 8 goes in both of them. So the answer is over here geometric sequence. Why? Because the common ratio is the same. Now, I would ask you, highly encourage you to pause the video, try this by yourself, and then continue to explanations. I hope you pause the video and try to solve it by yourself. If not even, you can pause it now. Now we will go to the explanation over here. See, take the two terms over here, last two terms. 16 minus 9, you're getting 7. Now, 9 minus 4, you're getting 5. No, it's not going to be arithmetic sequence. Let's try the common ratio. 16 divided by 9 is 1.7. Okay, let's go for the next one. 9 fourth is 2.25. No, this is not a common ratio as well. So this is just random numbers. Now it's not arithmetic sequence, nor it is geometric. You can see these are powers, So now 1 square is 1, 2 square is 4, 3 square is 9, 4 square is, 16. Next would be 5 square 25, 6 square 36, 7 square 49, and it would go on. So this is the pattern over here. But this is not arithmetic nor a geometric sequence. So that is the thing. And now we will go on to the last problem. I would again ask you to pause the video and try it by yourselves. Now let us see for the common difference. 5 minus 11 is minus 6. 11 minus 17 is minus 6. And lastly, we have 17 minus 32 is also minus 6. You do not need to check for anything else. Sorry. You do not need to check for the common difference, a common ratio, because we got the common difference equal in all the cases. So hence it is an arithmetic sequence. So that is the end of this lesson. I hope you have found this useful. If you have any doubts, please do put them in the comment section. I'll try to get back to you as soon as possible. Until then, happy learning. If you're not subscribed to my channel, please do subscribe. And if you have found these videos helpful, do like them. And also do share it with your friends. That would mean a lot to me. Have a great day. Happy learning.